Hi everybody. Today we're going to learn how to find the surface area of a cone. I have here a cone made out of paper. This is the base of the cone. It's simply a circle, and we can call the radius r. This part here is called the lateral surface. The length from the tip of the cone to the perimeter of the base is called the slant length. Let's call it L. Getting back to surface area, we can begin by first saying that the surface area of the entire cone is equal to the area of the base plus the area of the lateral surface. The area of the base is the easy part. It's a circle, and we know that the area of a circle is pi times the radius squared. Our radius is r. So let's plug pi r squared into our equation. Next, we need to find the area of the lateral surface. To figure that out, we'll detach it from the base and then unravel it. We get a shape which looks almost like a circle, but not quite. It's only a fraction of a circle. Just for the moment, let's pretend that we do, in fact, have a full circle. What would its area be? Again, the area of a circle is pi times the radius squared. Usually, the letter r is used to represent the radius, but we're already using the letter r to represent the radius of the base. The radius of this circle is L. So the area of this circle will be pi times L squared. Let's plug that into our equation. It looks like we're done now, but actually there's a mistake with this equation. Pi L squared is the area of a complete circle of radius L. Remember, when we unraveled the lateral surface of the cone, we did not get a complete circle, only a fraction of a circle, which means that we need to multiply this term in our equation by some fraction. What should this fraction be? Should it be 1/2, 2/3, 19/500? What? Actually, the fraction will be different for different cones. For example, if we unravel this cone, we can see that it is 1/2 the size of a complete circle. Whereas, if we unravel this cone, we can see that it is 3/4 of a complete circle. If we unravel this cone, we can see that it is 1/4 of a complete circle. So we're not going to be able to come up with a concrete fraction to put in here that works for every cone. However, we can use variables. We can say that the fraction is equal to the area of the lateral surface that's what we unraveled to get this incomplete circle, over the area of the complete circle. For example, let's say the area of the lateral surface was 4 square units, and the area of the complete circle was 8 square units. Then the fraction would be 4/8, which we can reduce to 1/2. Or maybe the area of the lateral surface was 6 square units, and the area of the complete circle was 8 square units. Then the fraction would be 6/8, which we can reduce to 3/4. Or maybe the area of the lateral surface was 2 square units, and the area of the complete circle was 8 square units. Then this fraction would become 2/8, which we can reduce to 1/4. So by using these variables, we get a formula that works no matter what the cone looked like to begin with. Now, I'm sorry to have to tell you this, but there's another problem here. We're using the area of the lateral surface to find the area of the lateral surface. That doesn't really make sense. That would be sort of like if your car went missing and your strategy to find your car was to get in your car and drive around. Obviously, that won't work. So here's how we're going to fix this problem. We're going to write this whole fraction in a different way by noticing that the ratio of this area to this area is the same as the ratio of this perimeter to this perimeter. For example, here we see that this area is half of this area, and this perimeter is also half of this perimeter. Looking at the next picture, we see that this area is 3/4 of this area, and this perimeter is also 3/4 of this perimeter. Looking at the next picture, we see that this area is 1/4 of this area, and this perimeter is also 1/4 of this perimeter. And we could go on and on. In general, the ratio of the areas is equal to the ratio of the perimeters. So we can go back to our equation and replace areas, A, with perimeters, P. Now we just have two perimeters to figure out, and then we're done. Let's start with the easier one. The perimeter of the complete circle is simply its circumference. And we know that the circumference of a circle is equal to 2 pi times the radius. In this case, the radius is L, so we can plug in 2 pi L for the perimeter of the complete circle. What about the perimeter of the lateral surface? If it were a complete circle, it would be easier, but it's not. So let's do something clever. Let's take our lateral surface and fold it back up the way that it started. Notice that the perimeter of the lateral surface is the same as the circumference of the base of the cone. Therefore, the circumference of the base is 2 pi r, which again is equal to the perimeter of the lateral surface. So we can go and plug that into our equation. We're basically done now. all that's left is to clean up or simplify our expression. The 2's and the pi's cancel out, and we can rewrite L squared as L times L. One of these L's cancels with this L in the denominator. And we can use the commutative property to rearrange this r and this pi. Now we can see that the surface area of a cone is equal to pi r squared, which is the area of the base, plus pi rl, which is the area of the lateral surface. However, when doing problems, it's sometimes easier to write this expression in a different way. First, write r squared as r times r. Then notice that both of these terms have pi r in them, so we can factor that out. The pi r is on the outside of these parentheses, and r plus L is on the inside. To see that this is really equivalent to this, just distribute. Pi r times r would give you pi rr, or pi r squared, and pi r times L would give you pi rl. So, sometimes the surface area of a cone is written this way, and sometimes it's written this way. Either way is correct for calculating the surface area of a cone. Have a great day.